What parent function is this? Quadratic, okay? This is the thing that we're going to talk about today. All the different transformations that a quadratic can make. Okay? Do you still see the parent function in there? You still see it, x squared? But hardly ever are we going to ever see it like that. It's always going to have some other stuff with it. So I want you to know what that other stuff does to the parent function. Okay? So let's start. What do you want to start with? A, B, H, or K? A. We're going to go linearly right down the row. Okay. So if we're starting with A, if it was by itself, it would look like y equals A times our function, right? Ax squared. You okay with that? Now, what is A doing to the x squared? It's multiplying, right? Now, some people say, well, it's sitting beside it. Well, I mean, I suppose that's true, but usually when numbers are sitting beside each other, that means they're multiplying, right? So A times x squared. We're multiplying A times x squared. A times x squared changes the shape of our parent function, okay? And it's called a vertical stretch or a compression. Anybody remember this? Vertical stretch or compression. So if I have a balloon, pretend I have a balloon in my hands. Okay? If I take the bottom of the balloon and hold on to it, and I take the top of the balloon and I stretch it, what's happening to the sides of the balloon? It's getting closer to each other, right? Whereas if I hold on to the bottom of the balloon and I compress the balloon vertically, what's happening to the sides of the balloon? It's getting wider, right? Okay, so a vertical stretch or compression. I need you to know just by looking at the A value whether it's a stretch or compression. If A is a stretch, if it's causing a stretch, A is going to be greater than 1. If it's causing a compression, A is going to be between 0 and 1. So what did I leave out? If A is less than 0, right? Well, that's a whole nother thing, okay? If A is less than 0, so if we have A is less than 0, so if A is negative, basically, if it's negative A, that's going to cause a reflection over the x-axis. Now, it doesn't matter if A is greater than 1 or if A is between 0 and 1 at this point, but if A is negative, that causes a reflection. So the negative sign causes a reflection, and then the value of A tells you whether it's a stretch or compression. Does that make sense? Okay. So it's like two different parts. Even though it's sitting right next to each other, it's two different things. The negative causes a reflection, the A changes the shape. Does that make sense? So, what do you want to do next? B? Okay. So if we're talking about B, it would look like y equals bx squared. Right? Well, what is B doing to the x? It's multiplying again, right? So, does it seem like it would be something similar? But the difference is it's inside of the function. The function that we've chosen is a quadratic. It's a squared, right? Can you see that this is outside of the function and that this one is inside the function? Well, because of that, this one causes a horizontal stretch or compression. Now, when things happen horizontally compared with vertically, it can trick you if you let it. So I don't want you to let it. Okay? Because here's the deal. Vertical stretch is when A is greater than 1. A horizontal, let's think about this. Think about the balloon again, right? If I have a vertical stretch, I'm taking this, each end, and I'm pulling it tight so the middle is getting what? It's closer together, right? Well, think about if I do a horizontal compression. What's happening to the sides? Ooh, they're getting closer together. So wait, how do you tell the difference whether it's a vertical stretch or a horizontal compression? If you're just looking at the graph, you can't. The only way you can tell is by looking at the equation whether the number is outside or inside. But does it make sense that if a vertical stretch is when A is greater than 1, that B is greater than 1 is going to be a horizontal compression? Does that make sense? Because we're vertical stretch and a horizontal compression, those should be the same thing, right? That's when these values are greater than 1. So what would cause a horizontal stretch then? Yep, when B is between 0 and 1. You okay with that? What if B is less than 0? You guys are so smart. If it's a negative B, it reflects over the y-axis. Okay? H, is that what you want to do now? H? Excuse me. Okay, if we're doing H now, where is H in relation to the function? Is it inside or outside? It's inside, okay? So if it's inside, what kind of change do you think it's going to cause? Look at A and B. Where was A? Inside or outside? Outside. Where was B? Inside. So what kind of change happened with A? Vertical. What kind of change happened with B? Horizontal. Okay. So where's H? Inside. So what kind of change is it going to cause? Horizontal. Okay. But here's the deal. It's not a stretch or compression anymore, right? That was already taken care of by A and B. What kind of thing is happening horizontally? It's a horizontal shift. Now, this is one of the most important things I'll teach you all year. Are you ready to listen to it? It is super important to remember your F in this word. Otherwise, it's a whole different word. Okay? Until somebody turns in a test and forgot their F. Oh, yes. I still have it around here somewhere. I'll see if I can find it and show it to you. Okay? What direction is horizontal? Show me with your arms. That way, right? So this direction is what? Left and right, right? So horizontal shift left or right. Well, here's the deal. This is another place that can be tricky if you let it. Okay? Think about what the formula says. The formula says x minus h. The minus is part of the formula, right? So if I look at this and see that my h is 7, it's going to say x minus 7, but the value of h is just 7. So 7 is a positive number, right? If it's positive, which way will it go? To the right. So if h is positive, it'll go to the right. But I need you to realize that what it's going to look like here is x minus h. Okay? X minus h is when the h is positive because the minus is part of the formula. The subtraction sign is part of the formula. Okay? Does everybody understand that? So how is it going to shift to the left then? If it's a negative h, but what's that going to look like? It's going to be basically x minus a negative h or x plus h. Do you see how that might be confusing? Because if I see x minus h, I think that's going left, don't I? I just have to remember, what I do is I remember it's opposite of what I think it's going to be. X minus h means I'm moving to the right. X plus h means I'm moving to the left. Opposite of what I think it's going to be. You okay with that? So what's left? Okay. Tell me about K. Smarty pants. Where is it in relation to the function? Outside, so what kind of change is going to happen? A vertical change. What direction is vertical? It is a shift, remembering your F's. What's going to cause a vertical shift up when K is positive? Positive K. What's going to cause a vertical shift down? A negative K. Questions? All pretty straightforward, right? So look and see where the thing is, first of all. What kind of change from the parent function? Where is it? Is it inside or is it outside? Because if it's inside, B and H both cause a horizontal change of some sort. A and K both cause a vertical change of some sort. It's either a stretch or compression or a shift, but you have to know if it's being multiplied or if it's being added or subtracted. Okay? Any questions about that? So here comes the part that some people struggle with, but not you. Not you. What if I started here? What parent function is that? Absolute value. So if I gave you this, except actually put those in absolute value bars. Tell me about A, B, H, and K. Boom. What if I gave you this one? What kind of parent function is that? So what if I gave you this? Tell me about A, B, H, and K. Boom. Every parent function that we have, those are still the same rules for them. You understand that? Okay, so what might happen then on your homework is it might give you a graph with an equation. Y equals 1/2 x minus 2. And it'll give you this graph, and it'll say, what's the parent function? Well, what's the parent function of this? If I ignore all the numbers, what's left? X. So what parent function is that? Linear. So I'd write linear. And then it'll say compare this with its parent. Well, what happens here? I have a multiplier that's outside. Linear is kind of tricky because it's really not outside or inside. It's just there. So we're going to say outside. Okay. What is a multiplier? What happens with a multiplier on the outside? Vertical. Stretch or compression? Compression? Why is it compression? So it's a vertical compression by a factor of 1/2. So we took care of that. What's left? The minus 2. What letter is that? That's K. So what does that cause? So a vertical shift down. How many? 2. Done. The other thing that might happen in your homework, so this one, it gave you a graph and said what's the parent and how does it change. The next thing it might happen is it might give you just an equation and say graph the parent and then tell me how it changes. So for instance, it might say this. What are you going to write for this? Well, if you have to graph the parent, what's the parent look like? Looks like absolute value, like a V, right? Now it'll give you a nice pretty graph so you can make it real good, right? Make it real pretty and nice. Well, so what's the parent? absolute value. How does it change from its parent? Describe the transformation. Well, what does that cause? A reflection. Where? Where is it? It's on the outside. So outside causes a vertical change. So if it's a vertical change, which axis is it reflecting over? X-axis. So that took care of that. What's left? The 4? So what does the 4 do? Vertical shift, up 4. Done. Any questions? Somebody asked me a question. My favorite baseball team is the Dodgers. And I also really like the Rangers too, though. But when I was 7, I played on the Dodgers. Not the actual Dodgers, but our little league team was the Dodgers. Oh no. Any more questions about your homework? You got this okay?